Um,
Hey guys, Kriben Govender from the Gut Health Gurus podcast. I've got a background in food science, and today I have a third time visit to the podcast, the first three-peater, Morley Robbins. Welcome to the show.
Look, I'm just thrilled to be here. I appreciate the opportunity to have yet a third. Either you've got lots of questions, or I just have too much to say. I don't know what it is.
Well, I'm really excited today to have you on and extremely grateful. The main reason that I wanted to have a chat is because a mutual friend of ours, Martha Carlin,
Oh, wonderful.
mentioned to me and has been sending some papers and some information about a special type of enzyme, which we're going to get into as we continue this conversation. But I just wanted to start off by just asking Morley, is there anything, because we're now in 2024, I think it's been a while since we chatted last time,
It
but is it,
hasn't.
but is there anything that you've kind of maybe changed your mind on, or something else that's piquing your interest at the moment?
That's a wonderful question. Um, every day is a new discovery, as you probably can imagine. Um, what's absolutely fascinating is it isn't that I've changed anything at this point. I mean, the we're we're revolving around the copper iron dynamic, which is revolving around oxygen status. We've talked about that. I think what's really come to light in a more intense way is just how dysregulated our iron is in our body. I, I think the scale of it is, it was described in an article I read this morning as the Trojan horse. And it's a beautiful description of it because we can relate to that. We know that story. Yeah, oh yeah, I know that Trojan horse story. Well, here's the wicked part. You're a nutritionist. You're very savvy about the microbiome. You must be if you're talking to Martha Carlin, who's a genius around the microbiome. And she'll probably be the only citizen scientist to win the Nobel Prize. That would be my theory. But there's a delivery mechanism for iron that I just learned about a few weeks ago. It's like, oh my God. So you've heard of sugar and you've heard of insulin, and we're going to talk about these hormones in a minute. But what I read recently, just a few weeks ago, and this is a 1983 study, which should make our sphincters tighten up. So that's 40 years. They knew this 40 years ago, that when insulin presents to a fat cell, there's a 2 to 3 fold increase in iron uptake in that fat cell. Did you know that?
No.
I didn't know that. It's like that sends a chill down my spine. And it's I don't think it's just fat cells. I think it's any cell, muscle cell, organ cell, gut, the enterocytes. Think about that. And so, but what's fascinating about it is it's a silent Trojan horse for delivering iron is the use of sugar. I mean, it's like, wow. And they've known this for 40 years, but no one talks about it. And the thing is, I've you're saying, has my thinking evolved, or what am I focused on? I really have boiled it down. Iron causes aging, and copper causes longevity. That's it. And if you can really internalize that and act on that, you're going to do pretty well. But if you start dancing with the pundits of the day and start getting lost in all of their verbiage, you'll lose sight of the big picture. And that's really what I'm trying to do is, I keep, I guess, what do the the chefs call it reductionist. You reduce,
Hmm.
I'm reduce. I keep trying to reduce the thought to its essence. And that's kind of what I've gotten to. Iron is aging and copper is longevity. And it's amazing how little the scientists and the practitioners know about iron.
So
Just
it's like you're almost going back to first principles or Occam's razor, that kind of concept. But I'd like to
yep.
just go back a little bit. So what's your thoughts on the significance of this study that you're talking about? So insulin, so you just go through a scenario, so you consume sugar or some
Yep.
sort of
Well,
something
here,
that influences the insulin response, and then what's the implication of this iron uptake, and why does it happen?
how much time? Do
As much time as you like.
we, right. Um, you're probably familiar with Robert Lustig. He
Yep.
wrote a really entertaining book called Fat Chance. He's written several books. Um, what's the one? Metabolism. Anyway, he's a really prolific writer, as you know. But he said something in this article, Fat Chance. The book was written in 2013, and is referring to a 30-year period earlier. And he said, we need twice as much insulin to clear the same amount of glucose as we did 30 years ago. Well, a lot of people have the service Audible. Well, my Audible is Dr. Liz. She reads to me while we're driving wherever we're going. And she read that sentence, and I almost had an accident. It's like, what? So the reason why that's so important is that means that copper is involved in glucose regulation and really extending the concept. Insulin is a backup plan. Insulin is a very powerful hormone, as you well know. But I don't think again, I take a somewhat contrarian view. I don't think the body runs on hormones. It runs on minerals, and hormones respond to mineral dysregulation, and they respond to oxygen status. But the body doesn't run on hormones per se. That's a very countercultural statement. But I think what's happened is farming has changed. Commercial herbicides and fertilizers are very prevalent. The one that's most prevalent is glyphosate. It chelates copper at a preferential rate that's outrageous. It'll chelate copper 1 billion times faster than it'll chelate magnesium. It'll chelate copper 1,000 times faster than it chelates zinc or iron. And these numbers begin to kind of gloss over. We can't relate to 1 billion times faster, 1,000 times faster. I mean, there was a time when I could run an 8-minute mile. And my son at that time, my younger son, yeah, I don't think my older son could have done it, but my younger son, he ran a mile in 4:02. So he was twice as fast. So
Wow.
I went to the gym just to see what that felt like, and I almost killed myself. And I realized that the machine was doing all the work, but that was twice as fast. 1,000 times faster, 1 billion times. We can't relate to this. And so when we find out that we need twice as much insulin, that means we have a copper crisis. That's what that really means. And I think that, to answer your question, why is this happening? Because no one's minding the store. No one's acknowledging the mineral concentration of the soil. Wonderful book, if you haven't read it, by Gabe Brown, Dirt to Soil. It's a beautiful, very, very simple, but very powerful study about how do we restore our soil? How do we get regenerative farming back in the mainstream? And if we don't know what the minerals are in the soil, we're not going to know what the minerals are in the plants or the animals, and therefore we're not going to know what's going. And people are so quick to use nutrient tables. They've got a lot of eye candy now, right? They're really cool online. but they haven't been updated since the 1950s. People don't realize that. They don't realize that data, garbage in, garbage out, it's garbage data now, because a lot of things have changed since the 1950s. At least I think they have, and I think you would agree. And so people, well, I'm eating copper-rich foods. I'm like, they're not copper-rich anymore. They're not mineral-rich. And that's the challenge, is that the concept of minerals is very boring. It's very, there's no sex appeal. And so it's not taught in doctor school. I'm not even sure it's taught in nutrition school, to be honest, at least to my satisfaction. And so people don't know these basic underlying components of our environment that have tremendous influence over our metabolism, over our ability to make energy, over our ability to signal and communicate. And so it's just, I think there's a gap in our understanding about where the problem really resides.
I'm not sure whether we've covered it in previous topics, but how does copper manage glucose?
That's a wonderful question. Oh, my computer's driving me crazy. You probably never have these problems.
Oh, I do. Of course I do.
It's like right in the middle of my screen. All right. All right. So we have two terms that are complementary. We have glucose intolerance and we have insulin resistance. They're not the same thing. They're interrelated, but they're not the exact same thing. And so glucose is an oxidant. It's very abrasive. Guess what insulin is? It's an antioxidant. Not just a hormone, it's an antioxidant. It's trying to calm down this beast of a food substance. And there is no one article, there's no billboard that says, here's the answer to your wonderful question about copper and glucose. But there's 1,000 different hints in the literature. And one of the more powerful ones is, 1986 article by Leslie Clavet. He'll be 90 years old this year. He's an MD, PhD. He's a cardiologist by training. He's a copper expert. And he wrote a wonderful article for your listeners in October of 2022 called Chronic Copper Deficiency. For those who aren't quite sure what this whole thing is about. And so if you don't have enough copper, iron's going to build in your system. Like that, they've known that since 1928. That's a well-established biological fact. And so in 1986, Dr. Clavet was studying two men who had hyperglycemia, high glucose, and he was really trying to understand what's causing it. And he made a very powerful observation that children with Menkes disease, now Menkes is a genetic defect where these children, and they usually die by the time they're 3 years of age, they don't have the copper pump, the ATP7A pump, to move copper into the enzymes to help regulate the body. And so they have next to no copper in their tissue. And so he makes the point that children with Menkes disease are glucose intolerant. Wow, that connected some pretty big dots there. And then you find out that you may have heard of the triopathy of diabetes. It's 3 conditions. There's retinopathy, neuropathy, the nerves, especially in the lower limbs, get very buzzed out. And then nephropathy, the kidneys go out. Well, those three conditions are taking place in tissue that is insulin independent. Insulin doesn't work in those three tissues. It doesn't work in the retina, doesn't work in the nerves, and does not work in the kidneys. It's absolutely wow. And so there's a backup mechanism for regulating sugar being traded off with sodium to get the sugar into the tissue, but it requires the presence of an enzyme called ascorbate oxidase. Most people have never heard of it. But ascorbate oxidase is a copper-dependent enzyme. So if copper is not present to regulate that flow, and we're getting into vitamin C metabolism, not ascorbic acid, vitamin C, it's a very different beast. And so we start getting into realms of research that most people are not familiar with. And then I think the third is the third hint, if you will, again, is we know that ceruloplasmin is the master antioxidant of the body. And its priority focus is to keep oxygen and iron at bay, keep them properly regulated so they don't cause oxidative stress. And it does this through the action of an enzyme called ferroxidase. Very, very important enzyme. I think it regulates a third oxidant sugar. And the reason why I say that is that in another article by Dr. Kriben, he talks about, or actually it was in this article from 1986, what happens in the state of hyperglycemia, high blood glucose, is it blows up the ceruloplasmin molecule, and then the copper comes out and gets oxidized, goes from copper 1 to copper 2, and it's immediately bound up by albumin. But albumin doesn't have the same metabolic properties as ceruloplasmin. And so there are many different references to copper status and sugar status, and that notion of ceruloplasmin blowing up was also written up in a 2019 article by two scientists from Russia. So it's not just old news, it's new news. And in a corollary fashion, people are probably familiar with estrogen, and they know that estrogen rises as we get older. It's well established. And what else is rising as we get older? Iron. So iron's going up and estrogen's going up. What's not being accounted for is copper and ceruloplasmin. So if ceruloplasmin is the master antioxidant, and when ceruloplasmin goes down, because copper status is going down as we age, then the body's got to go to the backup plan. So if iron is rising and there's not enough copper to run ceruloplasmin, the body's going to rely on estrogen. I think the same dynamic is taking place on the sugar side. If ceruloplasmin is not present, the body has to default to insulin as the backup plan. And there's a certain elegance and symmetry to that model. It's not like I have 100 articles to back it up. I'm really relying on my intuition, but my dot connecting, having read about 10,000 articles now over 15 years to try to piece all this together. It makes more sense to me from an operational standpoint, this idea that hormones run the body, that's never made sense to me from the get-go. And so it's a very disruptive idea, but I think it has more integrity, if you will, looking at it from that standpoint.
That's a very interesting summation, it's almost you've gone through a process of deduction, reasoning, Morley, and multiple studies on your own reading, intuition. So that's amazing. I think it makes complete sense what you're saying. So how do people actually? So if like estrogen's going up, insulin, the reliance on insulin is increasing as we age. How do we mitigate? And also, how do we manage these hormones better?
Yeah.
Is there any strategies that people can take from those insights to actually make a difference to their own lives?
Absolutely. I mean, first and foremost, what we have to do is lower our stress, right? And when I say stress, there's like 1,000 different forms of stress. But Mildred Seelig classified 4 different categories of stress. We have physical stress. You just fell down a flight of stairs. You were in a car accident. That's physical stress. Environmental stress. We've got all sorts of toxins in our water and our air and in our food, yada, yada. We have metabolic stress. We don't have the right nutrient profile in our body. We don't have we're not able to run the metabolic pathways. And as soon as the pathways don't work right, there's going to be oxidative stress, which is probably the greatest stress of all. And then the 4th stress is psychological or emotional stress. And when you use the word stress, that's what people think of as emotional stress. What people need to know is as soon as you go into a state of emotional stress, you are creating metabolic stress at a physiological level, and you're operating out of fear. And fear triggers very powerful hormones, triggers cortisol and adrenaline, but it's also triggering noradrenaline if you have enough copper to make it. And people don't think about the cortisol and the adrenaline response. And that response creates hypoxia. And when you say the word hypoxia, you think Mount Everest, top of Mount Everest, when in fact there's another form of it called functional hypoxia, where down inside the cell, there's not enough bioavailable copper to activate the oxygen to create water to release energy. So how do people deal with this? If they've got to lower their stress, what stresses you out may not stress me out, and vice versa. Yeah. Because we're all different, right? We've all had different experiences. But we all do have our perception of stress, bills to pay, got to get along in relationship, got to deal with our colleagues, what have you, got to deal with our neighbors and the bigger community, got to deal with the insanity of the world, right? The world's a lot different today than it was the last time we talked. It's a crazy world out there, and it doesn't seem to be getting any calmer. So we've got to be able to kind of get all that under wraps. We've got to lower the amount of iron in our tissue. It's just, again, a good rule of thumb for iron is to take your age and multiply it times 365. So I'm 71 times 365. I've got about 26,000 milligrams of iron coursing through my body. You can make the adjustment on your age. Well, we're designed for 5,000. 5,000. I've got 5 times that. And so my wife and I, we go to Red Cross on a regular basis to stay on top of our iron status. And because that's going to help us manage our oxidative stress. You gotta have a good diet. You've got to, you need to have supplements that we talk about in the root cause protocol. And in the last couple of years, one of the supplements that I really put a lot of emphasis on was copper. And I developed a copper supplement called Recuperate. And no, I've not become a supplement whore. I just know that there's a very serious shortage of this bioavailable mineral on the planet. And so I've decided to, and there are other people that are doing it. I'm not the only one, but I couldn't stay on the sidelines any longer. So I think it's important for people to know that if they're relying on nutrient tables and historical sources of copper, you might want to reinforce that. You might want to supplement that. And so within the root cause protocol, we focus on three minerals: copper and iron and magnesium. And what is important for people to understand is that we lose, in a state of acute stress, we lose magnesium very quickly. In a state of chronic stress, we lose access to copper. And we must have copper and magnesium to make energy. And what's getting in the way of copper and magnesium is iron. And so we're trying to simplify the model as much as possible to get people to realize that they can get on top of this, that they can control their personal environment and begin to bring greater balance and homeostasis back into their being.
So it sounds like all the foundational aspects of root cause protocol are still in play. Is there any changes you've made to the protocol or any adjustments?
We're always exploring. I think one of the adjustments that we will clearly make this year is Martha's sugar shift. I think it's an amazing product.
Amazing product.
Wonderful, wonderful product. And we're adding things like red light therapy, which makes obvious sense. What we're trying to be really careful of, and I think you can appreciate this along with your followers, is we could easily have 75 components and it would just overwhelm people. So we're really trying to be respectful of how we add to the base, but the bulk of the stops and the bulk of the starts are identical today to what they were when you and I last talked.
Right. So it's still those foundational aspects which are pretty solid.
Yeah.
And remind us quickly of the tenets of the root cause protocol, because I think some listeners might have no idea what we're talking about.
Yeah. So the origin of the root cause protocol was actually an article by Ray Peat on iron toxicity. I can't remember when he wrote it. It was like 2010 or something like that. It was an amazing article. And towards the end of the article, he made a very important observation. He said, to my knowledge, no one has ever come up with a recipe to increase ceruloplasmin. I thought, that's what I'm going to do. I love that. That's a great idea. And so the root cause protocol began with 2 stops and 2 starts. But the focus was on building more bioavailable copper. And now it's got about 12 stops and 12 starts. But the purpose behind it is to still increase the bioavailability of copper, make it usable. Why? Because you can't make energy without copper. You can't clear exhaust without copper. 45% of our connective tissue, 45%, the tendons, the ligaments, cartilage, the blood vessels, all of these different tissues, you've got collagen as strength and elastin as flexibility. And you've got to knit those 2 proteins together in order to give tissue its integrity, strength, and flexibility. Well, there's only one enzyme that does it. It's called lysyl oxidase. It makes all the connective tissue work properly. Color, can't live without it, right? Well, there's one enzyme that makes it possible. It's called melanin. Melanin colors everything from yellow to black. It's activated by another enzyme called tyrosinase. And what is tyrosinase? It's got 2 copper atoms inside it. And so you can't color the human body. You can't color any animal unless you have copper acting on that enzyme function. And so Um, you asked what's new. I'm gaga about the spleen.
Mm,
You know? Everyone focuses on the liver on the right side. I'm preoccupied with the spleen on the left side. It it's the hidden organ. Do you know what color the spleen is supposed to be?
no idea.
Yeah. So I didn't know either. Deep, it's the color of eggplant.
Right.
Deep, dark purple. And the deeper and the darker the purple, the more vitality and the more energy it's got. And I had a surgeon share with me recently. He said, Morley, I've never seen a purple spleen.
Wow.
And so what does that tell us? Well, it means that the organs can get vitiligo. We think about
Ah,
vitiligo in our skin, right? It's
yes.
not just skin deep, it's organ deep. And if the organs don't express the right color, they don't have enough energy. They don't have integrity of their function. And it's like it's so cool to think of it that way. And so um, copper plays these many faceted roles in the body that nobody knows about. And so it's the Achilles heel. You talked about Occam's razor. You know, let's focus on the least likely component that's going to have the biggest impact, and that's bioavailable copper. And it has this in, insane relationship with iron. It goes back to the beginning of time, and it's not understood in the right circles. The practitioners, the nutritionists, the doctors, the nurses, the whoever's don't realize this very powerful interplay between they're called redox active minerals. There are only two, copper and iron. Both have a relationship with oxygen. Redox is reduction, oxidation, the passing of electrons back and forth throughout the body. You understand that. But the thing is, it doesn't just happen, it's regulated, it's managed. And copper is the general, and iron is the foot soldier. And you don't have to be in the military to know generals have more brass, more stars, right? Made of brass. And what's brass made of? Copper, 88% copper. And so copper runs the show, but nobody knows that. And especially the gut. And this is where Martha and I go bonkers, is she's always telling me about the bacteria running I said, yeah, but they don't work unless they've got a battery. And she's go, okay, you got me there, right? Okay. So we go back, we have these Jane Curtin, Dan Aykroyd conversations. And we've come to finally accept that, yeah, you can't without the microbiome and the minerals, it doesn't work. And so that's the beauty of bringing, minds together to say, how do we solve this problem?
Completely. I think each aspect has its own place to play, and there's
Absolutely.
probably things that we haven't even discovered yet. So
No, no,
it's a great position to be, to keep a relatively open mind to learning these new discoveries as they emerge.
yeah,
So
yeah,
the next thing, I think it's clearly highlighted out how important copper is, but I'm sure that the audience are thinking, okay, there's one way to get more copper is to have a supplement, something like your supplement.
yep,
Are
yep.
there any food-based interventions that people can use?
Yes, but let me qualify it. I was reading an article about a month ago from 2017 that was profiling the epidemic of chronic kidney disease in India with their rice farmers, and they use glyphosate. And glyphosate, again, chelates copper, which will lead to intense oxidative stress, which leads to what's called kidney disease because of the iron accumulation that results. But in the article, in the introduction, they said, It would be useful to tell you about a recent study done in France. France was vehemently opposed to glyphosate, going back to the very beginning, against the law to use glyphosate in France. But in this 2017 study about Indian rice farmers, they make mention of the fact of a study, previous study, that profiled that 99% of French people have glyphosate in their urine. That's a very chilling fact. That means it's in the air. That means it's
Wow.
in the means it's in the water. That means it's everywhere. And so people have simply got to wake up to the fact that organic farming doesn't mean what we thought it meant. Back in the 60s, it meant something. Now, 60 years later, it's a joke. Do you know that organic farmers are allowed to use glyphosate now?
Oh, God.
Because it's got carbon in it. So anything that has carbon is okay. It's a brave new world. And so historically, sources of copper-rich foods would have been organ meats, grass-fed organ meats, seafood, mollusks especially, nuts, seeds, leafy green vegetables. These are all known. Lentils, you know. Here's a good shorthand. Any food that's been turned into GMO was a good source of copper. Corn, soybean, sugar beets, alfalfa. Why do you think they did that? It's like, it's just, it's wild, Kriben. Like, we're up against a really evil empire,
Yeah.
and we just have to be. And I'm laughing not because I'm dismissing it. I'm trying to be playful about it. It's like, oh my God, if we got really morose, we just get so depressed about it. It's like, wow, they really